Okay guys, sorry I'm not with you this afternoon. We're going to carry on with Pythagoras today. So you've done a couple of lessons now working on Pythagoras where you were always working out the hypotenuse, the longer side. What we're going to look at this morning is looking at Pythagoras with the shorter side. So that's your heading. You can copy that down in your jotter, please. Okay, and again, like we have said before, we don't need to draw the triangle every single time we're doing a question, but I want you to draw these first three triangles, okay? We'll just do it one at a time, so you can just draw the first one. I'm just going to draw the others to get myself started, okay? And we'll draw these three examples, and then this should be enough to help you get on with the sheet. Okay, so we know that in order to work out a missing length in a triangle, we need the two other lengths. And what you've been used to doing before, guys, is working out the hypotenuse, the longest side, which we've said most of the time is going to be the slanting side, but it's always the side opposite the right angle. So what happens if instead I give you that length? So I'm going to tell you that this length here is 5, and I'm going to tell you that this length here is 4, and we're going to be working out the shorter side. We're going to be working out x, okay, which is one of our shorter sides this time. Now, the eagle-eyed among you might realise we've already done this question, and therefore you'll know the answer, but that's why I'm picking this one first. Now, from what we did previous, guys, you would have told me, right, well, 5 squared, because that's the longest side, the hypotenuse, is going to be the same as x squared plus 4 squared. But that's not going to help us here because we're trying to work out x, and at the moment x is involved with the 4 on this side. So what we need to do is we need to rearrange this in a way that we have it as x squared instead. Now, if we think about what we do when we do equations, we to move stuff about, remember you do the opposite. So this is a plus 4 squared, but we really want it on that side with the 5. So the opposite of adding 4 squared is taking it away. Okay, now we don't need to do that every time. You can, if you realise that you're working out a shorter side, so one of these two sides that makes up the right angle, if we're working out one of those, you can just remember that the Pythagoras is going to be a subtract. Wee bit of alliteration for you, shorter side subtract. That's a good way to remember it. Okay, but then we just do everything else like we've done before. So you would take your calculator, or in this case we can manage this one without a calculator. 5 squared is 25, 4 squared is 16, so we've got 25 take away 16, and 25 take away 16 is just 9, so we're going to have x squared is 9. X then is going to be the square root of 9, and we should know that as 3, and that shouldn't be a surprise to us, guys. We've spoken about this idea of the 3, 4, 5 triangle before. Okay, so nothing is different from the work you were doing last week, apart from because we're working out one of the shorter sides, we have a subtract instead of an add. That's the only thing that's different. The lines of working that I expect to see from you are the exact same. You should always have the formula like this with the numbers in place. We don't worry about writing the actual formula. We should always have this line here. Okay, this line here you can have if you want, especially if you were doing this without a calculator, but we're using calculators today, so it's not a problem. You always need to show that you're taking the square root, and this one worked out nicely, so we just have our answer. Remember, if it doesn't work out nicely, you need to show your unrounded answer first before you show your rounded answer, and we'll get onto that in the next example. So, if you haven't already, try and draw the next triangle for me, please. And we're going to put the right information on that we need. So we're going to be working out this length here, which is x. Okay, it's one of the shorter sides. As soon as you see that, you need to be thinking, right, it's a shorter side. I need to do a subtract Pythagoras. The other two sides, let's call this one 21 metres. And let's call this one 19 metres. Okay, so we start off by writing out the version of Pythagoras that we need. We're just going to start with x squared this time. We don't need to start with the 21 because we're remembering that we're working out a shorter side, so it's going to be a subtract Pythagoras. Now, hopefully you guys will understand why, but always start with the bigger number. So we're doing 21 squared take away 19 squared. If we try and do that the other way around, you're going to get a negative number and that's not going to work. So you always need to start with your bigger number when we do the takeaway versions. Okay, so we're going to have x squared is 21 squared take away 19 squared. So we need to work that out. Remember, you need to know where the squared button and the square root button are on the calculator. Okay, so 21 squared take away 19 squared gives me an answer of 80. Okay, so then we want to get rid of that squared sign. Remember, to do that we have to take the square root. So we're going to work out the square root of 80, but you need to write it down like that first of all. And then we give our unrounded answer, so the big long answer you get on the calculator, 8.94427 and so on. And now the question you're all going to ask me, how many decimal places will we round it to? I'm going to round it to 2 decimal places here. The worksheet that you're going to do today, you've been asked to round them all to 2 decimal places. So let's just get in that habit. And so this one would be 8.94, and this time the question was in metres. So paying attention to your units as well, guys. Okay, lines of working that we need and making sure we've got units on our answer. Okay, final example, similar idea. We are going to be working out this side here, which is x. Let's do this one in millimetres. Okay, now obviously that's one of our shorter sides. It's one of the sides that makes up the right angle. Okay, so that should be triggering in our head. It's a subtract. Now, every question you're doing today, guys, it's going to be a subtract. We're not at the stage yet where we're going to kind of muddle them up and sometimes it's add, sometimes it's take away. We'll get to that later on in the week. Okay, we need lengths for our other sides, so we're working in millimetres. Let's go for 52 millimetres for our hypotenuse. This other side obviously has to be shorter than that. Let's say that that one is 20 millimetres. Okay, so we've got all the information we need. We were looking at our question. We're realising it's a shorter side, so we need to subtract. So x squared is going to be something squared take away something squared. Okay, we always put our bigger number first. So we've got 52 squared take away 20 squared. Okay, and that's what we're going to need to work with in our calculator. So 50 squared take away 20 squared, type that into your calculator. You should get 2,100. Okay, now from there, x is the square root of 2,100. So we write that next. Remember, you need to write that down. You can't just leave it and jump straight to the next line. Make sure as well that that 2, that little squared sign, has gone from your x. Unrounded answer first of all, folks, 45.8257 and so on. That's enough to help me round it to 2 decimal places. 45.83, because remember that 5 means the 2 rounds up, and this one was in millimetres. So hopefully those 3 examples are enough. Your teacher can let you watch the video again if you need to, and it is available on YouTube if you want to look at it at home later on to help you. But you've got the other side of that worksheet that you were working on Thursday. Plenty questions there to keep you going. You don't need to draw the triangle, but I do want to see this as you're working. So you should have 5 lines of working every time, unless it works out as an exact value answer. Okay, where you don't need to round it. 5 lines of working for every single question, folks. Okay, that's what our good answer looks like. That's what we're aiming for today. And I will see you tomorrow.